Dear friends, now we will discuss about coordinate systems. So see here, so this is the coordinate systems we have used. So in the 7th standard, so we will be knowing about this quadrant slide. So the coordinate system includes 4 quadrants and the sign convention in each quadrant should be taken. So we need to remember what quadrant and the values x value and y value in that particular quadrant. So we have totally of 4 quadrants, Q1, Q2, Q3 and Q4 all represents the quadrants. And see here in this quadrant, so x value and y value both are positive, and in this quadrant the x value is negative and the y value is positive, and in third quadrant both are negative, and in fourth quadrant so the x value is positive and the y value is negative. So we have the main quadrant system here is, so first one is Cartesian or rectangular coordinate system. So sometimes we call it as Cartesian or sometimes we call it as rectangular coordinate system also. In this type of coordinate system we have the first category is absolute coordinate system. So what does it mean? So the coordinate system in which the coordinate values are calculated with reference to the origin point. So 0, 0, origin point is 0, 0. So if you calculate each and every quadrant coordinate values by taking the reference as the origin point, so that type of system is known as the absolute coordinate system. So and this is the graph, it appears like this, and see here there is 0, 0. So this is the origin point. So if you go rightwards from the origin point, the values will be positive, and in the similar way, so if you go upwards from the origin point, the values will be positive, and if you go leftwards or downwards from the origin point, those values will be negative. So if you want to draw the components or any parts, so by using this absolute coordinate system, so we need to use the syntax. Syntax means we need to follow the rule. So we need to give the x value and we need to give the y value to complete the diagram by using this absolute coordinate system. So now we will draw one object by using this absolute coordinate system. So we will be knowing deeply by drawing that. See here, so I have a diagram like this. See here I have a diagram like this, and I need to complete this diagram. So this length is 2, this length is 2, 2, 2, 2, 2, and this is 6 and this is 6. So this is the dimensions of this diagram. So we need to complete this by using this absolute coordinate system. So how to draw this component by using absolute coordinate system? So let us look into this. So before going to draw any component, so you need to first set the units. So go to command line, type UN for units and press enter. So check that this type is in decimal and the precision value I need only 1. So 1 value I need. So the unit, see, insertion scale is in millimeters. So I am clicking OK. So I have set the unit system millimeters. And now after setting units, so you need to set the limits. So go to command line and type LIM for limits and press enter, and set the lower left corner as 0, 0, 0, 0 and press enter, and set, so upper right corner I am setting to, so the maximum value here is 6. So if you go 6 and 6, so give greater values about that. I am giving some value 50, 50 and press enter. So after giving a limit, so you need to use the command zoom Z and press enter, and you need to type A and press enter, zoom enter and all enter, so that the working area will be appeared clearly. So now the syntax you need to follow while drawing the components by using this absolute system. So the first rule is, so you need to take the reference point as origin, and the second rule number 2 is you need to use x and y values only to complete the drawing. So this is the, so I am taking this line command. So first point, so to give the first point you need to give only x and y values only. So I am giving the value 0, 0. After giving the values you need to press enter. So see, it will take the origin point 0, 0 from this point, and now it is asking you to specify the next point. So now I have given the first point here. See, this point is 0, 0. This is the origin point. See, this is, so now to here, right? See, I need to draw a line here. So what is the distance in x direction I need to move? So see, this is the distance I need to move in the x direction. The x distance is 2, and I don't want to move in y direction, right? So y is 0. So I only want to move only in x direction, that is 2. So, and I don't want to move in y direction. There is no distance in y. So now give the values here, x and y values, and we need to give. So how much we need to move? I need to move in the x direction 2, 0. Why I don't want to move? So press enter. There it creates a quadrant value. See, a coordinate value it is creating 2, 0. And now we need to move the line, or we need to create a line, to here. So while drawing in this absolute coordinate system, so for each point you need to calculate the coordinate values. So for this point you need to calculate the coordinate values. So what is the coordinate value of this point? So I need to move x to, the distance is 2, so the distance is 2, and I need to move the distance 2. So this is the distance 2. See, it has represented here. So I need to move 2, 2. So the coordinate value of this point is 2, 2. From the origin only we need to calculate. So from the origin I need to move the distance 2, and in the x and the y direction I need to move the distance 2. So that if you give this coordinate value, so the point will be getting to here. So I am giving the value 2, 2 and press enter. See. Now now we are here and we need to go here. So now calculate the coordinate value of this point. So how much is the x distance to here? So I need to move in the x direction. So this is 2, this is 2. So it is 4. From the origin only we need to calculate each and every coordinate values while drawing in this absolute coordinate system. So how much I need to move in y direction? So I need to move in y 2. See, the y distance is only 2, but the x is 4. So if you give the value x 4, 2 and press enter, see, now we are here. So we are here and we need to go here, right? So if you want to go here to this point, I need to move the x value 4, and I need to move the y value also now 4. So this is 2 and this is 2. So 2 plus 2, 4. So 4, x value is 4, and we need to move to this point, right? So this is 2, the distance 2, and this is 2. So totally we got 4. So if you give 4, 4, then the point will be here. And now we need to go here, right? So to this point, what is the distance? The x distance from the origin. So the x distance is, see, x distance is, we have given here, see, 6. So we need to move in the x direction 6, and in the y direction, see, this is 2 and this is 2. So this is 4. So if you give the value 6, 4, then the point will be appearing here. And now calculate the coordinate values to this point. So how much we need to move in x and y? So this is the point. So x direction we need to move 6, and in the y direction also we need to move, see, this is the y direction, and we need to move 6. So this is the point. So if you give 6, 6, then the point will be going to this point. And now if you want to come here, so how much we need to move in the x direction? I don't want to move, so there is no distance in the x direction. From the origin only we need to calculate. I am telling you again and again. So from the origin point, so we need to move the point 6. The distance is 6 in the y direction, and in the x direction there is no distance. So see, this is the y direction, that is 6. Here there is coordinate value of this point. So if you give 0, 6, the point will be appeared here. So now we are here and we need to come to the original position, right? So if you want to come to the original position, what should you do? So again you need to give the point 0, 0, so that it will meet to the starting point. So I am giving value 0, 0 and press enter, and again press enter to come out from this line command. See, this is the diagram by using absolute coordinate system, we need to calculate the point, these coordinate values with reference to this origin point only. So like that you need to give x and y coordinate values so that the point will be getting to the exact coordinate values. So if you give the dimensions here, see this is 6 and see this is 6, this is 2 and this is also 2 and this is 2, this is 2, this is 2, everything is 2. The dimensions are 2. See, all these dimensions are 2 only. So this is the diagram. In this way we need to complete the diagrams by using this absolute coordinate system. Now I am deleting this. So now see here, Cartesian coordinate systems is, the first one is absolute coordinate system and the second one is the relative coordinate system. So what does it mean? So the coordinate system in which the coordinate values are calculated without taking the reference as the origin point, but by taking the previous point as the origin point. So this type of system is known as a relative coordinate system. We are not calculating the coordinate values with reference to origin, but we need to calculate the values by taking the previous point as the origin point, and we need to calculate the coordinate value point, and we need to calculate the coordinate values, and we need to complete the diagram. So what is the syntax here? So we need to use this syntax @ we need to use this @ symbol, and we need to give the x value and y value so that it will be completed. See, this is the graph, it appears, and in the similar way here you have observed this. So from the origin if you go rightwards, from the origin if you go upwards or rightwards, so the values will be positive. From the origin if you go leftwards or downwards, so the values will be negative. And you need to use the syntax @ x value and y value. So while drawing the objects you need to follow two rules if you are willing to draw by using this relative coordinate system. So the first rule is, so you need to take the reference point as the previous, you need to take it and you need to calculate the coordinate values, and you need to follow the syntax @ x value and y value you need to give. So now the same diagram we need to draw in this relative coordinate system. So again I am taking the line, we have already set the limits and units, everything. So I am taking the line, I am giving the first point as @ I am giving x value 0, 0 and press enter. So that, see, the point is starting here. This is the origin point in this relative coordinate system. So now, so this is the previous point. So we have created this point, right? So to calculate the coordinate values of this point, so you need to take the reference as this origin point. So I need to move 2 in the x direction and I don't want to move in y direction. So the value is @ if you give this value, so I am giving @ 2, 0 and press enter. See, the line is, and now if you want to go up, now if you want to draw the object here, if you want to create the object here, so what is the distance? Now you need to take the reference point as this and you need to calculate the coordinate values of this point. So now @ so this is the reference point and I am considering it as origin point. So @ I need to move, this is the origin point, I need to move in y direction 2 and no x direction I need to move. So 0, 2. I need to give the values @ 0, 2. Why 0, 2? So I don't want to move from this point, I need to move 2 upwards. So now @ 0, 2. I am giving the value 0, 2 and press enter. See, the point is going up, and from here we need to calculate this point. So what is the quadrant point of this? So this is the reference now. This point is our reference, and @ I need to move x direction from this reference point. So I need to move 2 as this length is 2 and 0. I don't want to move anymore in y direction from this point. I am giving the value @ 2, 0 and press enter. See, the point is appearing here. And if you want to go here, the point you need to go here. So @ you need to go in y direction 2 and x direction 0. So the point is @ 0, 2. The point will be, see, I am giving the value @ 0, 2 and press enter. See, the point is here. And now if you want to go to here, so this is the reference point now, and you need to go in the x direction 2 and no distance and 0 distance in y direction, right? So go to command line, type at the rate x direction I need to move 2 comma 0 and press enter. See, I am here, and now I need to go up. So this is the reference point for me, and I need to go up. So in y direction I need to move 2 and no x direction, x distance is not there. So at the rate 0 comma 2 I need to give and press enter. So the point is here. Now from here I need to go to here, right? From here I need to go to here, right? From this point I need to go here. So for this I need to move this in negative x direction. This is the origin point, and from the origin point if you go leftwards or downwards, so you need to use these negative values. So x is negative, and if you want to move in y direction also, y will be also negative. So now, so we need to move negative x direction, that distance 6, and now y direction is there. So what is the quadrant value of this? So at the rate x distance I need to move minus 6 comma 0. So at the rate to come here, so it won't take at the rate 0 comma 0. If you give the value at the rate 0 comma 0, it won't take. So if you want to come to the original position, and from this point you need to come down, so you need to give the value at the rate no x distance I am moving, so 0 comma minus, so we are coming down. See, in y direction the distance 6 I need to move downwards, so it is negative. So if you give at the rate 0 comma minus 6, then you will meet this point and again press enter to come out. See, in this way the diagram has completed by using this relative coordinate system. See, I am deleting this. So now there is the second type of coordinate system here, which is known as polar coordinate system. The first one is Cartesian or rectangular coordinate system, and the second type is polar coordinate system. And in the first one there are two types, absolute and polar coordinate systems. And in the second type there is one type, so which is known as relative polar coordinate system, which means the coordinate system which combines both absolute and relative coordinate systems, and it focuses on the distance in x or y direction and the corresponding angle. So this type of system is known as relative polar coordinate system. So totally we have three coordinate systems. So one is absolute coordinate system, and the second one is polar coordinate system, and the third one is relative polar coordinate system. So most frequently used coordinate system is this system. The relative polar coordinate system is most frequently used, and it is the easiest method among these three. So you need to use this. So it is the combination of absolute and relative coordinate systems, and you need to follow the distance and you need to follow the corresponding angles in this coordinate system. So this is the diagram it shows. So before what we have done, so from the coordinate system if you go rightwards or upwards, so we have used the positive values, and from the origin point, so if you go leftwards or downwards, so we have used the negative values. So now in this case, so from the origin point upwards, so we need to use how much distance you are going from the origin to the rightwards, and you need to use this 0 degree angle if you go straight right. So if you go straight upwards, so you need to use the how much distance you are going upwards from the origin point, and you need to use this corresponding angle as 90 degree. And from the origin point if you go straight leftwards, so for that, so how much distance you are going, and you need to use this angle 180 degree. So in the anti-clockwise direction, see, this is the 7th standard angles, right? So this is 0 degree or 360 degree, and this is 90 degree, this is 180, and this is 270 degree. So if you go downwards from the origin point, so how much distance you are going downwards, and you need to use this corresponding angle 270 degree. So the syntax you need to follow here is at the rate distance less than, you need to use the symbol less than, and you need to give the angle, the corresponding angle, see, in x direction, in y direction, and in negative x and negative y directions. So you need to use the corresponding angles, so to complete the drawings by using this relative polar coordinate system. Now we will complete this diagram by using this third type of relative polar coordinate system. So I am taking line command. So I am giving the first point as at the rate distance is 0 less than 0 degree and press enter. So the origin point is taken here in this system, and now I need to come here, right? I need to come here point. So now what should I do? At the rate to come here, what should I use? So I need to move the distance 2 and I need to use the less than symbol, and it is in 0 degree. The angle is 0 degree. So this is the syntax we need to use to come to this point. So at the rate 2 less than 0 and press enter. See, the point is here. So now if you want to go to here, now what should you do? So at the rate, so we need to move 2 in the upward direction. So the distance is 2 and less than, the angle is 90 degree. The corresponding angle is 90 degree, because from this point I am going upwards. This is the origin point and I am going upward. This is the origin point before and I am going rightwards. So it is the corresponding angle, and here 90 degree is the corresponding angle. So now at the rate 2 less than 90 degree, press enter. See, the point is appearing here. And if you want to go here, so I is taking this as the reference point and I need to move in the x direction 2 less than, again I need to use the 0 degree angle because I am going rightwards. So again at the rate 2 less than 0 and press enter. See, I am here. Now if you want to go here, this point, so taking as this reference, so at the rate I need to move 2 distance less than, the angle is 90. Very simple method is this method. So at the rate 2 less than 90, press enter. And if you want to at the rate 2 less than 0 degree, so at the rate 2 less than 0, see we are here. So if you want to go here, so at the rate the distance is 2 less than 90 degree I need to move. So at the rate 2 less than 90 degree. From here, and this is the reference point, and we need to go here, right? So we need to move at the rate, we need to move the distance 6 less than, so we are going leftwards from this point. So the angle is 180 degree. See, we need to use the angle 180 degree because this is the reference point. We are going leftwards from the origin point. So we need to use this corresponding angle as 180. So at the rate 6 less than 80, press enter. See, now we are here. So if you go at the rate 0, 0, 0 or 0 less than 0 also, you cannot come to this point. So what should you do? So calculate this point. So at the rate you need to move the distance 6 less than, so the angle is 270. See, the angle is 270 because this is the reference point and we are going downwards from the origin point. So we need to move 6 distance and from the origin, so it is 270, the corresponding angle in downward direction. So for that reason, so at the rate 6 less than 270, press enter, so that the point will meet to the starting point and press enter to come out. So by using this coordinate system, so the components will be completing in this way. So this is the most frequent way, and you need to learn more and more about this relative polar coordinate system, and it is the easiest method to create any type of drawings. So you can learn this method, so it will be very useful. And now so while dealing with AutoCAD, so we need to remember some of the paper sizes. So as civil engineers or mechanical engineers or any electrical engineers, so any engineer dealing AutoCAD, so they must be know about the paper sizes, how the paper sizes will be, and the standard sizes also they need to be known. So see here, these are the paper sizes. So this horizontal length, if you measure a paper, so this is length and this is width, right? In the 7th standard or in the 5th standard we have learned about this. This is the length and this is the width. So if you take the paper in this vertically direction, so this type of mode is known as the portrait mode. So we have two modes of paper sizes. So first one is the portrait mode. What is portrait mode? So this is the length and this is the width. So if rectangular view appears in vertical direction, that means, so if length is less than width, so here length is less than width, so in that case it is known as the portrait mode. And see here, so this is the landscape mode. So this is the length and this is the width, right? So if you turn the paper 90 degree and if you look this paper, so the rectangle appears in the horizontal direction. So this type of paper orientation is known as the landscape mode. So this is the one paper orientation. So this is the one paper orientation, and this is the second type of orientation. So depending on the orientation of the paper, so there are portrait mode and the landscape mode. What happens in landscape mode? This length is greater than this width, and in portrait mode this length is less than this width. And see here, if length is less than width of the paper, so it is in portrait mode, and vice versa will be applied to the landscape mode. So see, these are the standard sizes of papers. So from A0 to A10 we have the papers. See, these are the maximum size papers, and we have legal papers also. So depending on your requirement, you can take the printouts of those drawings into any paper size. So see here, this is A0, the suffix is 0, and this is the standard dimension of this. So one is length and width. L for length and B for width. So this first dimension represents length and the second dimension represents width. So these values are in millimeters. So these are in millimeters, and if you, so depending on your orientation, the view of orientation, so it is in portrait or it is in landscape. So these are the dimensions in portrait mode because length is less than width. See, length is less than width. So if you reverse these values, so it will be in the landscape mode because the length is greater than width. So as the suffix value increases, the paper size decreases. See, A0 size is 841 by 1189 millimeters, and if you go to the A1, paper size A1, so 594 by 841 millimeter. So the size has decreased. And if you go on A5, A6, A7, see, we are most frequently using this A4 size papers. So the dimension of this paper size is 210 by 297 millimeters. 210 is for length and 297 is for width. So if you go to this A10 paper size, so see how much it has reduced. 26 by 37 millimeter size is the A10 paper size. See, if the suffix values for A, the alphabetical A, so those will be, if the suffix values increases, the paper size decreases. So if the suffix value is less, so the paper size is more. So we are most frequently using this A3 and A4 paper sizes. So civil engineers mostly using this A3 size and A4 size papers also. So see, different types of papers sizes you need to remember for your reference. See, these are all for your reference. So once go through it, so you will be know some information about the paper sizes. And these coordinate systems we will be using mostly in the coming videos because we need to draw the objects. So for that, so the coordinate systems will be very useful. So you need to learn about these coordinate systems.